that what that would look like? I never thought about that. What would it look like if a rocky planet crashed into a gas giant? Because, like, there wouldn't be any immediate, like, explosion. Because, I mean, the gas isn't a solid surface. Would it just kind of absorb like that? Because Neptune doesn't look like it gives too much of a shit here. Let's do Earth at 500 degrees Celsius. As you could guess, probably, everything is dead. Moving on. Now, here's Earth at 1,000 degrees Celsius. Things have not improved. In fact, they've probably gotten a bit worse. It is glowing now. Not good. Now, here's Earth at 2,500 degrees Celsius. It's pretty bright. Not a good vacation spot. You're definitely going to want some sunscreen. Okay, so now it's getting ridiculous at this point. We're about 5,000 degrees. Sun is nowhere to be found. I don't know where all this heat is coming from. I don't want to know. Good morning. Well, good morning. It's definitely gonna be. Let's turn my volume down a little bit. It's definitely gonna be afternoon by the time anyone sees this at best, unless you're like somewhere else in like Europe or something. This is gonna be like nighttime, or it might be tomorrow. If you're in like Australia or something, it might be morning. All right, whatever. So look, right. Welcome to 2019. Okay. The year of me getting my shit together. I'm just trying to adjust my mic here. This microphone stand is so cheap and just horrendously broken. Okay. Alright. So, welcome to SarcasticDragon's stupid astronomy lessons. No, this is probably not going to be a series. Unless you want it to be. Maybe. I don't know. But, like, I don't know what else to play right now. And this seems like some fun. So, I apologize if there's going to be any performance issues. There might be. Because, like, we're recording and stuff, and I don't know, I've had issues with this game before, because it tends to be very computationally taxing in terms of CPU and physics and whatnot, but we're gonna learn today. You're gonna learn. I know, the stuff I'm gonna tell you, I already know, it's like, but anyways, so, welcome to our solar system, yeah? You're probably familiar with this. There's not a whole lot to look at here. I mean, there is, but, you know, let's move on to something a bit more interesting, yeah? Random galaxy. This is, it's a galaxy. Actually, I could give a quick explanation of dark matter. What is dark matter? I don't fucking know. No one knows. Right now, at least. It does not look like this. It's not red. It's not anything. Can't see it. Because it doesn't interact with light. The only reason we know it's there is because, like, there's, like, a lot more gravity going on. Like, there's a lot more gravitational force going on in many places than there should be, and, like, so there's gotta be something there that's acting on it, and so we just call whatever the fuck that is dark matter, but we don't know anything about it past that, really. Ah. Good shit. So right here, right, we've got, okay, alright, we got the Parker Solar Probe. So this was launched in August? Of just this last year, and is going to the sun, as you might have guessed. It's passing really close by. I don't exactly remember what its mission is. I really should read up on that again. But the interesting thing about this is right here, what we've got here, this big flat panel right here, this is to protect it from the sun. And then all the instruments are back here. But this is mostly just to protect it from the sun. I don't really remember how all the stuff is getting around it and stuff. But interesting stuff. I don't really know a whole lot about it, though, other than that. So, moving on. Alright, so what we got here is a galaxy collision. Now, this is presumably between the Milky Way and the Andromeda, yeah? Because these two, they're fucking into each other, right? And they're headed right for each other at about, like, I don't know how fast they're going towards each other. So we're moving at about a million years every second. And so let's slow this down to real time so we can see what you would see if you were out here watching this. So 1 second. Okay, it went down to 0. Basically the same thing. So I don't know which. This is Milky Way. This is Andromeda. We're gonna crash into each other. All right, let's go back up to. Look, man, I don't use this thing. So it's I mean, they're really into each other, as you can see. There's gonna be a lot of swirling. It's been 100 million years already. And when this ends, it's just going to be a giant ball of stars. Won't be nearly as pretty as it is now. It'll be an elliptical galaxy. It's just going to be a big, bright blob. So let's see if we could see that happen. We're moving at 10 million years a second. It's been 350 million years almost. Something tells me this isn't going to end anytime soon. Let's do Earth at 500 degrees Celsius. As you could guess, probably, everything is dead. Moving on. Now here's Earth at 1,000 degrees Celsius. Things have not improved. In fact, they've probably gotten a bit worse. It is glowing now. Not good. Now here's Earth at 2,500 degrees Celsius. It's pretty bright. Not a good vacation spot. You're definitely going to want some sunscreen. Okay, so now it's getting ridiculous at this point. We're about 5,000 degrees. Sun is nowhere to be found. I don't know where all this heat is coming from. I don't want to know. Here's 10,000. So at this point, the Earth is just kind of evaporating because it's at this point, everything is reaching its melting point. So, I mean, yeah, this is not going to last very long. If you go up to 100,000, yeah, it's over in a matter of seconds. So, anywho, oh, here's a good one. This is a good learning one. All right, so what we got here is Jupiter being very close to the sun. Now, this is much closer than Mercury is to the sun. Now, obviously, fun fact, Jupiter is not that close to the sun, but it's actually pretty common in other solar systems for giant gas planets to be that close to the sun. And as far as I know, we have no idea why. It doesn't make sense to us. We're still figuring it out, but yeah, they tend to sort of get eaten alive by their star. It's not a fun process for the planet, I'd imagine. I don't know, but either way, it's pretty much game over for old Zeusy here. Earth and 8 Cereses. So Ceres is the largest object in the asteroid belt, I think. I don't know why this simulation is a thing. Why 8 specifically, and why Ceres? They're in stable orbits, so there's not going to be any boom booms. Boom boom. Anyway, alright. Here's the moon if it was a lot closer, apparently. Oh, it's getting torn apart. I'm still alive, for now. Don't know how long that's going to last. I mean, either way, this is going to heat up the planet so much I won't be for long. But for the time being, I'm okay. And apparently the power grid is still up, so that's good. Like, yeah, that's almost hitting the atmosphere. But, I mean, it's been doing that several times, so maybe this is just how it's going to stay. But either way, not a very good day. Definitely worse than the whole dinosaur thing. No one's, yeah, I don't think those lights would be staying on in real life. Moving on. Alright, so here's one you may have heard about. TRAPPIST-1, right? So, what we've got here is some colors. These are not there in real life. It's a visualization, okay? So, this is the TRAPPIST-1 star system, okay? And this is a representation of the habitable zone. The green there is called the Goldilocks zone. That's where you want to be if you want to, you know, not die. If you're in the blue, you need a coat. You're in the red, again, sunblock. But, so, TRAPPIST-1 was interesting because we found, supposedly, 7 of them in the 7 rocky planets in the habitable zone. Except, doesn't look like there's 7 here. I see 3 in the habitable zone, 3 in the hot zone. I mean, that one's like, that one's pushing it. And then we got 2 more. 1. We got 1 in the Goldilocks zone. Yes, I said that. Deal with it. And TRAPPIST-1 is a red dwarf, to my knowledge. So the habitable zone would be a lot closer to it than it is with our sun. But, you know. So you got a little bit more radiation, maybe. And actually, I believe some of these planets are tidally locked, and which is like our moon. And what that means is that they're set up so that they're rotating, so that they're always facing the star. So there's a few problems with that, right? That means one side is going to be freezing and one side is going to be scorched. So you'd kind of have this like narrow band in the middle where things would be okay, like just around like the center of the planet, kind of like the equator, but like vertical, like it'd be going north to south. And so you just have that narrow band that'd be okay. And a lot of this, I can't remember where I read this, but because it absorbs a lot of light, and there, a lot of the life forms there would probably be like really black. I think, maybe, again, don't quote me on that. I can't remember where I read that, but there you go. Potentially hazardous asteroids. So, as you might guess, this is tracking all of the potentially hazardous asteroids that we've found, and it is a bit of a clusterfuck. Now, when you look at it like this, you realize how much space there is between every object, and it suddenly doesn't become that surprising that nothing is anywhere near hitting us. But still, I mean, geez. Let's look at Ceres crash into Earth. All right. You could have started a little bit further away, so I could have gotten to a good view. But okay. So, a lot of dead stuff. Got a lot of tsunamis, like really big ones. I'm talking like probably a few kilometer high waves. Yeah, all the lights have gone out now. That's about right. Oceans probably should have evaporated by now. I would suspect, but actually they appear to be. Yeah. So that's well above boiling. About double that. But I'm sure you knew that. Not very green anymore. All the plants, they're taking a nap. And as the water evaporates, the atmosphere is going to get thicker, which just means it's going to get hotter, probably. Again, I think I know my stuff, but don't quote me on this. Neptune and Earth. Is that what that would look like? I never thought about that. What would it look like if a rocky planet crashed into a gas giant? Because, like, there wouldn't be any immediate, like, explosion. Because, I mean, the gas isn't a solid surface. Would it just kind of absorb like that? Because Neptune doesn't look like it gives too much of a shit here. It's like, it looks like it's just like, oh, hey, what's up? And our temperature is now 758, so it's a lot warmer than it was before. But, yeah, it doesn't seem too fazed by what just happened, which... I don't... It's kind of scary, man. Let's watch a supernova, as opposed to a galaxy. So, let's say the sun nova. So this is if the sun, which it's not gonna go supernova. The sun isn't. It's not big enough for that. But supernovas, they tend to sort of outshine their entire galaxies, which that's not what this one here is doing. But you can definitely see where it's happening, right? Random galaxy. This is, it's a galaxy. Actually, I could give a quick explanation of dark matter. What is dark matter? I don't fucking know. No one knows. Right now, at least. It does not look like this. It's not red. It's not anything. Can't see it. Because it doesn't interact with light. The only reason we know it's there is because, like, there's, like, a lot more gravity going on. Like, there's a lot more gravitational force going on in many places than there should be. And... like, so there's got to be something there that's acting on it, and so we just call whatever the fuck that is dark matter, but we don't know anything about it past that, really. Now, this here is a binary pulsar. Let's just go over what a pulsar is. It's just two pulsars going around each other. But a pulsar is what happens when, sometimes, when a star goes supernova, but it's not quite enough to form a black hole. It's just a little too low. Then you get a neutron star. And there's a couple different kinds of neutron stars, and there's pulsars, and then there's magnetars. And from what I know, magnetars are a lot more rare. Usually you get a pulsar. And so what you're seeing here is these are jets of radiation that are just shooting out of the out of the poles of each pulsar. And if you zoom in here, you can see that they are spinning quite rapidly. And the funniest thing is this isn't even real time. This is about 75% of real time. So they actually do spin this fast. And that's kind of fucking nuts. It's only a 12 kilometers across. So, small city. And, but it's still got the mass of almost 2 suns. You definitely don't want to get caught in one of these beams. It'll vaporize you, and then you're just not going to have a fun time. It's going to ruin your day. You're going to be out, like, looking at stars, space tourist, you hit by that, fucking dead. Now, here's something actually related to that I can show you here. Let me... Saturn? No, I want Voyager 1. Where is it? Oh, alright, there you can barely see it there. Not well enough to make out any of the details. That's the little golden plate. Oh, you can't see my mouse cursor, can you? Well, you can see it there, right? It's reflecting the light. So that's like a message to aliens, right? And I actually know what some of it means, but I don't feel like pulling up a picture. Okay, so got a lot going on here. Now, I don't know what this stuff means. I don't remember. Or this stuff. This is like a hydrogen atom, I think. Oh, wait, no, I think this is instructions on how to play the record. Yeah. And then what we got here, it's like 2 hydrogen atoms bonded together, something like that. Again, I don't really remember. But this right here, this is a map of the galaxy. And it shows you how to get to Earth. And how it does that is, this is why I was saying it was related to the pulsars, because this shows a bunch of different pulsars in the galaxy and shows them in relation to Earth. So, you know, like the center here, that's Earth, and then you've got all the directions out to the different pulsars, and so that sort of shows, you know, where Earth is in relation to you know, everything else. But that's all I remember on what all this stuff means. I feel like that one's on the tip of my tongue, but I don't remember. Oh wow, we've been going for 30 minutes now. Alright, well, I got some stuff to cut out. Thank you guys so much for watching this video. Thank you for learning with me on this fine day. If you want to learn more, go watch SciShow, Joe Scott, Seeker, Vsauce. I mean, these aren't all strictly... oh yeah, SciShow Space. If you want space, go SciShow Space. That's all they do there. It's pretty great channel. Let's see, who else do I watch? I watch a lot. Alright. But anyways, that's all I've got for now. Thank you guys so much for watching this video. If you liked it, maybe click subscribe or like it or comment, say Sarcastic Dragon, you should talk about this or that. If you want to learn about something with me, ask me. I know I'm great with paleontology. I was actually gonna be a paleontologist once upon a time, and then I found out that the job market was so thin that my guidance counselor, you know, the one who's supposed to know a lot about careers, she didn't even know it was still a thing. So I decided that was probably a bit too thin a job market for me to be getting into. But I know a lot about that. We'll find a way to be doing stuff with that. Maybe we'll play like Jurassic World Simulator, that game, or whatever. Despite how inaccurate it is, can you play that? So, let me know. But, welcome to 2019. We're back to regularly scheduled programming. I butchered that phrase. But thank you guys so much for watching this video, and I will see you guys next time. Peace out.